Now we are going to talk about synthetic division. That's in polynomial. So in our previous lecture, we talked about how we divide polynomial using what's called long division technique. Now this is same type of division, but we're going to use slightly different technique to divide between polynomial. Okay, so synthetic division. Let's say we need to divide x to the cube minus 4x to the square minus 5. Let's say we need to divide this by x minus 3. Well, we can definitely set it up as we did last time using the long division case, but there's another technique that we can use, and that technique of division is called synthetic division. Now setup is relatively easy. What we are going to deal with, we are only going to deal with the number in front of each term. If you remember, the name of the number that's located in front of each term, like variable in front of variable, remember that number, name of that number, it's called coefficient, right? Coefficient. So we are only going to deal with the coefficient. So what do we have in here? X to the third. Well, we have 1. What do we have in front of x squared term? Well, we have negative 4, right? You write the number with the sign, right? What do we have in place of x term? Well, remember that we don't have x term here. We have x to the third. Second, we don't have x term. So x term, we're just going to write 0. What about a number term? We have number term as negative 5. So I guess, we have to be careful that we need to put this 0, which was x to the square term. I mean, not the x to the square term, sorry. The x term, which we do not have here, yet we need this 0 to hold that place, All right. Now we are going to divide this. I'm going to divide this by, well, we used this whole term in here in our previous case, but this time we are only going to use this number, which is negative 3. But when we actually write this number, we are going to flip the sign and we are going to use 3, not negative 3, right? So even though this was negative, when we actually write here, there's no negative here. It's going to be plus 3. So, let's say if this was plus 5, if this was a plus 5, then we would have wrote negative 5 there, right? So sign has to be opposite. The sign has to be opposite. Because this was a negative, then we're going to write positive, right? You always flip the sign. If I make one more comment, see this part? What do we call this? This was a dividend. This was divisor. Divisor has to be in that format. This divisor has to be x plus something or x minus something format only. Right? It has to be in that format. Writing looks really bad. Well, so x plus something, x minus something. It can't be x squared. It can't be x to the cube, any other power. Or you shouldn't really have a number in front of x. Well, technically there is a way to bypass that, but we're not going to deal with that case. So for synthetic division, we assume that we only going to have x plus something or x minus something only. And this, just like this case, we have x plus something or x minus something only. All right. So this is how we set it up. This is how we set it up. Once we set it up like that, we're gonna draw another line right here. Leave some room because we're gonna write some numbers here. We're gonna draw another line, and this first number, we're just going to bring it down and write right there. Right? First number is just going to bring it down. And this number 3 is going to be multiply to here, and put it right here. So 3 times 1 would be 3, right? 3 times 1 would be 3. Okay, once we write it like that, then what's next? The next step would be combine these two together. So we're gonna add these two together. We're gonna add these two together. So when we add this together, negative 4 plus 3, and that becomes negative 1. Right? You add and put it right there. Now what's next? We're gonna multiply again this to here, multiply, right? Let me just circle. Multiply 3 to this number and put it right above here. So 3 times negative 1, now it's going to be negative 3. And what do we do with these two? Well, we add, right? We add. So 0 plus negative 3 would be negative 3. Now what do we do now? Again, we're going to do the same thing. We multiply this to this and put it right here. So 3 times negative 3 would be what? Negative 9. Negative 9. Then what do we do with these two? Again, we add. So negative 5, negative 9, that would be negative 14. Negative 14. And this last number that we have, we're going to set it aside. And this is going to be our remainder. This is going to be our remainder. Right? This is going to be our remainder. So we are practically done. You just need to know how to interpret this solution. So we got these result, and we're going to put it in that actual answer format. So let's go backward. This would be the number term. This would be x term. And what would that be then? Number x term, this would be x squared term. So combine this coefficient with the actual term. This first number 1 would be interpreted as x squared, 1x squared to be precise. And this one would be negative 1x. We'll skip the 1, right? And the number. That's it. This is our answer. This is our answer with remainder 14. Negative 14, right? This number right here. So if we have to put the proper answer form, you can leave it like this, or you can rewrite it as x squared negative x negative 3 plus our remainder negative 14, still yet to be divided by our original divisor x negative 3, right? X minus 3, right? So there you go. this is our final answer. Now, common form of example in this topic would be something like this. So let me write the example. Example goes something like this. Use synthetic division to show that x plus 3 is a factor of this polynomial, say 2x to the fifth plus 5x to the fourth negative 2x to the third plus 2x squared negative 2x plus 3. I mean, this example may look a little bit strange. However, let me tell you, this would be very, very common form of example. So if professor or teacher like to test synthetic division, instead of directly asking you to do the synthetic division, they might use this type of format to test whether you know synthetic division, plus whether you have concept of factor. Now, what if this is actually a factor of this long polynomial? If it's a factor, then what would happen? If it's a factor, when you divide this long polynomial with this divisor, remainder should be, think about the remainder. If it's a factor, remainder should be 0, right? That's what that's one of the way that you can show that this is a factor of this, because if this is a factor, if you divide this, then you shouldn't have any remainder. All right, so what we need to show is that divide this long polynomial by this and show that remainder is equal to 0, and we have to use synthetic division, right? The question is specifically saying use synthetic division. All right, so let's set it up. Let's set it up. Let's see if we can do this. So remember, we are only dealing with this coefficient. So 2 from here plus 5 next. Remember that we do not have any missing term. We have 5, 3, 4, 3, 2, 1 and number. So we don't really have any missing term. If we did, then we would have wrote 0 to hold that place, right? So that's this 2, and next one should be negative 2, and number term should be 3. And we're going to divide this by what? Remember this 3 right here, then we're going to put it here. But when we put this 3, what do? We switch the sign. This was a plus 3, so now this becomes negative 3. Just like that. Negative 3. Okay. What was the next step? Let's go back to previous one. Once we do that, kind of messy, but once we set it up, we wrote this line right there, right? Wrote this line. So, okay. We're gonna write line underneath, and we're gonna bring this first number down like this. This would be multiplied to here, put it right here. Negative 3 times 2 would be what? Negative 6. And what do we do with these two? We add and put it right below this. So 5 plus negative 6, negative 1. Okay, and we're going to do the same steps, right? So now negative 3 is going to be multiplied to negative 1, which becomes what? Which becomes 3. And we add these two together. When we add, this becomes 1. Multiply negative 3 to 1 would be negative 3. Add these two, negative 1. Negative 3 times negative 1 would be positive 3. Add these two, becomes 1. And looking good, right? Because I'm expecting negative 3 there, right? Negative 3 times 1 would be negative 3. And when we add this finally, it's 1. And this would be our remainder. So showing that the remainder equals 0, so x plus 3 is a vector. Because remainder is equal to 0. There you go. That's our answer. All right, so try a couple of other examples, and you should review this question if you have any question or trouble. Okay.